Okay, multiplying numbers with decimal points is really, really easy, assuming you can multiply whole numbers. Because we're going to do this exactly like if we're multiplying whole numbers, but then one little trick at the end to figure out where the decimal point goes, and that's it. So I'm going to show you the rule, show you how it works, and then I'm going to come back and explain why the rule works. It seems sort of crazy that the rule should work, but it turns out it's very logical. And so I'll explain why it works. And for me, that helps me to remember the rule because it makes sense, okay? And maybe it'll make sense for you that way. So here's the way you do it. Let's start with these decimal numbers. Here it's 4.3. This doesn't have a decimal, but at least this one does. And I'm going to ignore the decimal, pretend the decimal's not even there. So I'm going to treat it like multiplying 43 times 12. Notice the multiplier has two digits, so I'm going to have two rows and add them up. But that's the same as for working with whole numbers. Okay, 2 times 3 is 6, 2 times 4 is 8. We're done with the first row. Now I take 1 times each of these. Now your teacher might have you put a 0 here. I don't usually do that. I just leave it blank. But what you need to do is make sure when I go 1 times 3, I put the answer right here under this column here. So 1 times 3 is 3. Now, if it helps you to get that in the right place by putting a 0 there, there's nothing wrong with putting a 0 there. It's up to you or it's up to your teacher. So if your teacher thinks it's important to put the 0 there to help you get the right answer each time, well, try it that way, okay? So here I took 1 times 3 and I got 3. 1 times 4 and I get 4, okay? Now, we add them up. Here's the 6. 8 and 3 is 11. Carry the 1. 4 and 1 is 5. 516. But 516 is the answer to a problem that's too big, because that's 12 times 43. I don't want 12 times 43. I want 12 times 4.3. And so the rule is this. Count up how many places there are behind the decimal in the problem. In this case, for instance, there's 2 here and there's 1 here. In this case, there's only this 1. There isn't anything here, so it's just 1. Come down to your answer, and starting at the end of the number, move over 1, because there's 1 place behind the decimal. So 1, and that's where I put my decimal point. So the answer is 51.6. Does that make sense? Is that reasonable? Well, let's look at this with rounded numbers. This is sort of a good way to check things. This number is a little bit bigger than 4. This number is pretty close to 10. If that were 4 times 10, I'd get 40. And this is close to 40, it's 50. But look what would happen if I put the decimal in the wrong place. If I put the decimal over here, that would be 5. That's way off from 40. If I put the decimal over here, I have 500. That again is way off. So there's one of these places I could put the decimal that'll get the answer sort of close, and that's a good way to at least check that you got the decimal in the right place. Let's try this one, and then we'll come back and explain why both of these work. So we're going to take 421 times 25, just ignoring the decimals to start with. 5 times 1 is 5. 5 times 2 is 10. Carry the 1. 5 times 4 is 20, plus 1 is 21. 2 times 1 is 2. Notice I'm leaving that blank. You could put a 0 there like I did here. I'll just leave it blank for now. So 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. Add them up. 5, 2, 4 and 1 is 5, 8 and 2 is 10. 10,525 is the wrong answer because it's the answer to the wrong problem. 421 is much bigger than 4, and 25 is much bigger than 2.5. So this answer is much bigger than it should be. So count up the places behind the decimal point for both of these. Here's 1, 2, 3. So there's 3 places past the decimal in the problem. So we start at the end and we move it 1, 2, 3, and that makes the answer 10.525. Is that reasonable? Well, this number is between 2 and 3, and here we have something pretty close to 4. If it were 2 times 4, it would be 8. If it's 3 times 4, it would be 12, so we're looking for something sort of in between. And 10 is sort of in between, isn't it? Okay, so it looks like this is pretty close to what we expect. If I put the decimal here, it would be 1 point something. That's clearly wrong. If I put it here, it's 100 and something. That's clearly wrong. This is the only place to put the decimal that's even anywhere close. So it looks like we got it in the right place, okay? Now, why does this work? And by the way, nobody ever taught me why this works when I was in elementary school. I just figured it out because, hey, I do math a lot. And I pondered this and I thought, what's going on here? And I say, oh, that's what's happening. So I'll show you. So maybe it'll help you remember this if you actually understand it. Look at this. If I ignore the decimal and treat this like it's a 43, that's equivalent to moving the decimal to the end of the number. If I move the decimal over here, I get 43. So I don't have to write a decimal in there, do I? So ignoring the decimal is equivalent to moving the decimal to the end of the number, so I move this decimal 1 place to the right. Now, in a previous lesson, we saw that moving the decimal point 1 place to the right is multiplying by 10. So what we've done is we've made the number 10 times bigger. So now we go ahead and do the problem, and we got 516 as our answer. But that answer should be 10 times too big because we multiplied the problem by 10, and so that multiplies the answer by 10. To get the correct answer for the original problem, we have to divide by 10, or in other words, move the decimal 1 place to the left to compensate for moving it to the right up here. And that's the trick. What about over here? If I ignore the decimal here, that's equivalent to moving it to the end of the number. So it looks like 421. That's like multiplying by 100. 10 times 10, that's 100. And here, to move this to the end of the number is like multiplying by 10. So 1, 2, 3 zeros. This is like 1,000 altogether. So I've multiplied the problem by 1,000, and so the answer is going to be 1,000 times too big. And so I have to divide by 1,000 to make up for it. And there you go. I could think of it as move it 2 places for that, and move it 1 more place for that, or just add them up and say there's 3 zeros, move it 3 places, or realize that's 1,000, divide by 1,000. However you picture it, that's why you have to move it here. So by ignoring the decimal, we don't talk about it that way, but it's equivalent to moving the decimal to the end of the number. And when we get done, we have to reverse that process to make it the right answer for the right problem. Okay? That's all there is to it. There's really nothing more to say, so I'll stop talking.